Hello Math 130 students, we are going to pick up on page 6, section 7.2, solving quadratic equations by the quadratic formula. So the quadratic formula is given to you as negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's used to find any quadratic equation. To help solve any quadratic equation. So remember that quadratic equation is a degree 2 polynomial. So we already know about factoring, we know about the square root property, and we know about completing the square. So this is just something else to help our skill set, so the quadratic formula. The best way to go about this is to go ahead and identify your a, b, and c and plug it into your formula. So we have that our a value is 14, the b value is a negative 10, and the c value is equal to a positive 1. So when I have negative b plus or minus the square root of b squared minus 4 times my a times my c all over my 2 times my a. So notice how I am putting parentheses around everything that I'm going to be plugging in. So everything that's going to have a b value, I'm going to go ahead and highlight. So this is a b and that's my b. So what I'm plugging in there is going to be a negative 10. Now I have my a value. So my a value is here and here. So that a value is going to be 14. And now I can see my c value going in here, and that c value is 1. So now I have that x is equal to, well, this is a negative 10, so it's a positive 10 plus or minus. And here, I'm going to go ahead and do this on my calculator over to the side. So I have a parentheses, negative 10 squared minus 4 times 14 times 1, which gives me a 44 inside. And I have 2 times 14, which gives me a 28. So to simplify this a little bit, I can split this up. I have 10 over 28 plus or minus the square root of, and here the square root of 44, when I simplify that, and remember 44 is 4 times 11, so that 4 is 2 times 2. So I have 2 squared times 11. So if that's inside the square root, then we know that the 2 is going to jump out. So I have a 2 square root 11 over 28. And now I get to reduce the fraction. So 10 over 28, they both have a 2 in common. So if I divide by 2 on both sides, I have a 5/14. And I also have a 2 divided by 28, so I can divide by 2. So up on top, I'm going to have a square root 11, and in my denominator, I'm going to have a 14. And so that ends up becoming my final answer. Now for number 2, it's the same process, except I don't really have my a, b, and c identified. The reason why is because it's not in that ax squared plus bx plus c. So in order to get it into that general form, I'm going to have to distribute. So I'm going to have to distribute that 2d into the parentheses. So I have a 4d squared minus 10d plus 1 is equal to 0. So now I can say that my a value is a 4, my b value is a negative 10, and my c value is a positive 1. And remember that formula is negative b plus or minus the square root of b squared minus 4ac all over my 2a. So negative b plus or minus So the first thing I'm going to plug in is my b value. So that b value is a -10 that I'm going to be plugging in. Now for my a value, I have a +4 that I'm plugging in. And for my c value, it's a +1. So I'm going to get here that this is a +10 plus or minus. And now again, I have a -10 inside my parentheses squared minus 4 times 4 plus times 1, which is an 84. And 2 times 4 is equal to 8. So again, I can split this up. I have 8 in the denominator, and my numerator here is 10. And if I'm looking at the square root of 84, well, I know that this can be, oops, there we go. So 84 divided by 4 gives me a 21. So this is 2 squared times 21. So I know that this 2 is going to jump out. So my final answer, when it's everything simplified, well, if I have 10 eighths, I divide by 2, so I get my 5/4. And if I have my 2 eighths, that's going to reduce, so my numerator stays the square root of 21, and now that new denominator is going to be a 4. So that ends up becoming my final answer. For number 3, it's almost in that general form. I need it to equal to 0, so I'm going to add the 1/5. So I'm really going to have a 1/2 m squared plus 3/4 m plus a 1/5 is equal to 0. So now I can say that my a is equal to a 1/2, my b is equal to a 3/4, and my c value is equal to a 1/5. So I'm going to have -b plus or minus b squared minus 4ac all over my 2a. And again, like I said before, I like to put in parentheses where I'm going to be plugging in values. So that first value that I like to plug in is going to be my b value, so that's going to be my 3/4. And then the a value that I'm going to plug in is a 1/2. And then my c value is a 1/5. And again, remember guys, you are allowed to be using a calculator. So this is a -3/4 plus or minus, and this is where I'm going to be using my calculator. So I have a 3/4 inside parentheses squared minus 4 times your fraction of a 1/2 times your other fraction of a 1/5. And you end up getting 13/80 all over 2 times your 1/2, and you get a 1. So since that's a 1, you can actually ignore it. So this is really a -3/4 plus or minus the square root of 13 over the square root of 80. And if I were to have the square root of 80, that can simplify a bit more. So my final answer, I'm going to have x is equal to a -3/4 plus or minus the square root of 13. And 80, when you break it down, I have a 16 times 5, so that's a 4 squared times 5. So you can see that that 4 jumps out. So you have a 4, and you have a square root 5. And it really just kind of depends on your homework. But if they want you to also rationalize the denominator, then I would multiply top and bottom by a square root 5 just to go a bit further. So now I would have that x is equal to a negative 3/4 plus or minus, and 13 times 5 is 65. And now I have a 4 times 5, which is going to be a 20. So that is going to be my final answer. That is a simplified answer, and I had rationalized the denominator. Now for number 4, this one I am going to have to distribute. So I have a 5x squared minus 10x plus 7 is equal to 0. So I have a negative b plus or minus the square root of b squared minus 4 times a times c all over my 2 times my a. And so that b value here is a negative 10 that I'm plugging in. My a value is a positive 5. And that c value that I'm plugging in is a positive 7. So I'm going to have 10 plus or minus. And again, I have a negative 10 squared minus 4 times 5 times 7, which is going to give me a negative 40 over 10. When I split this up, I have 10 divided by 10 plus or minus the square root of negative 40 over 10. So don't forget that whenever you have a negative inside the square root, that's going to turn into an imaginary number. So x is equal to, well, 10 divided by 10 is just 1. So I have I square root 40 divided by 10. And you can simplify that, because if I were to have 40, that can be broken down as 2 squared times 10, so that the 2 can jump out. And so now I'm going to have 1 plus or minus, and the 2 and the 10 cancel, so you have I square root 10 over 5. And that is about as simplified as you can get with this answer. Now, since we talked about the quadratic equation, we can talk about the discriminant. So remember, the entire quadratic formula has that negative b plus or minus the b squared minus 4ac all over my 2a. Well, the discriminant is just the stuff underneath the square root. That's the only thing we're thinking about. So we're just focusing on, hey, if we look at what's inside the square root, it's going to tell us about the answer. So that's pretty cool. So we know that if it is greater than 0, so if it's a positive number, then we're going to have 2 distinct real numbers. So positive number has 2 distinct real numbers. If it's exactly equal to 0, then you have a single real number solution. And if it's going to be a negative value, then it has no real number solution, so it's going to be imaginary, okay? So for example number 1, it says find the discriminant. So, okay, so if I'm thinking about the discriminant, remember, I'm going to be thinking about my b squared minus 4a times c. So here, I'm going to plug in my values. So I have my b squared minus 4 times my a times my c. So here, you can think of your b value as a negative 1. You can think of your a as a negative 4. And you think of your c as a positive 4. So that b value is going to be a negative 1. The a that I'm plugging in is a negative 4. And that c value is going to be that positive 4. So when I plug that into my calculator, negative 1 squared minus 4 times a negative 4 times 4. And that gives me 65. So then for part A, when I talk about the discriminant, I know that it's equal to 65. So this is a positive number. Since it's a positive number, it's greater than 0. So I'm going to be looking at this first one. So for part B, I'm going to say it has a single number solution. Oh, sorry. I wasn't seeing that right. I'm looking at the first one, which means that it has two distinct real number. Okay. And then for part C, well, it says use the quadratic equation to find the solutions. So you already did half the work. So if I'm going to do the rest, well, I have a negative, and that b value that I'm plugging in is a negative 1. And I have plus or minus the square root of 65, because we already figured that out, all over 2 times your a value, which is a negative 4. So you get 1 plus or minus and the square root of 65. And at the bottom I have a negative 8. And it was 65, not 64. Okay. And that ends up becoming your final answer. You could, if you wanted to, say this is 1 over negative 8 plus or minus the square root of 65 over negative 8. But since it can't be simplified, I prefer that first one. Now, example number 2. It says, without actually finding the solutions, determine whether the following equations have two distinct real number solutions, a single real number solution, or no real number solution. So here it doesn't really actually tell you what you're using, but you're basically looking at the discriminant, which is that b squared minus 4 ac. So here my a value is negative 1, my b value is negative 10, and my c value is a negative 45. So I'm going to have my b squared minus 4a times my c value. So I'm plugging in negative 10, negative 1, and negative 45. So plug this into your calculator. And I end up that this is equal to a negative 80. Well, since it's negative, remember, we're going to be looking at less than 0. So if this is less than 0, this is your negative. So it looks like it has no real number solution. And we know that because the answer was equal to a negative number, which is less than 0. So we're going to do the exact same thing with part B. So here I'm going to have my, I'm going to have my a value as 25, my b value as 30, and my c value as a positive 9. So now when I plug it in, I have a b squared minus 4a times c. So that b value that I'm plugging in is a 30, a is 25, and my c is equal to 9. So let's see what type of answer I'm going to get. And I'm going to use my calculator. And I get equal to 0. So here, since my answer is exactly equal to 0, that's exactly equal to 0, then it has a single real number solution. So it all depends on that value of the discriminant. Okay, well, if you guys have any questions, please feel free to email me or the Math Success Center or our tutor. Thank you.